Hello all, welcome back to Coder. Let us solve the weekly contest problem, the number 3, and this is the third problem, and it is quite tricky, and I would say it is a medium problem because to crack this logic we want to analyze a little bit. So let us solve the problem. So the problem is the make number of distinct characters equal, and what does the problem states? You are given two in zero index strings, word 1 and word 2. You move consists of choosing two indices I and j such that I is in the range of word 1 length and j is in the range of word 2 length, and swapping word 1 of I with word 2 of j. So return true if it is possible to get the number of distinct characters in word 1 and word 2 to be equal with exactly one move. That is, we have to do exactly one swap, and in one swap we want to say word 1 is having distinct characters equal to word 2 distinct characters. So we want to return false if it is not possible at all. So here the example 1, as you can see, the word 1 is AC and the word 2 is B, where word 1 has two distinct characters and in word 2 we have one distinct characters. So if we swap A with B, then also we cannot make equal distinct characters with between word 1 and word 2. Even when we swap C with B, we cannot do it. So we return false. So in example 2, the ABCC and AAB, we can swap this C, and with one character A from word 2, and if we swap them, this word 1 becomes ABAC and word 2 becomes CAB, and the number of distinct characters in word 1 is 3 and the number of distinct characters in word 2 is also 3. So it is possible to make it equal distinct characters between word 1 and word 2 when we do one swap. So we return true. So hope you understand the problem. And how can we solve this problem? So the brute force problem is the brute force solution is swapping each and every character with each and every characters in word 2 and trying out whether it is whether they are having whether they are having equal distinct characters between word 1 and word 2. But it will give a time limit exceeded because the constraints are 10 power 5 and we cannot achieve 10 power 10 solution. So what we can do is, first we can take the frequency of the two words, that is frequency of every characters in both words. So I have initialized to map in the sense I am since there is only going to be lowercase characters of 26, so I have initialized two array of 26 size. So and I'm taking the frequency of both the words, or if we or else we can also have one instead of incrementing each time, but I have just incremented. I have just counted the frequency of all the characters in both word 1 and word 2. So what I have done here is, now I am going to do all possible swaps. So in previously in brute force we will be doing a swap that will be very high length string, that is n power 10 power 5 and into 10 power 5. But here what we can do is, we have restricted the range to 26 characters, 26 alphabets. So now we can try to do every possible swaps. So what we can do is, for each and every character in map 1 and for each and every character in map 2, what I'm doing is, first I'm finding which index is having greater than 0. If it is equal to 0, I am just giving a continue, and I can just eliminate these two lines. I thought we had to take this. Okay. So what I have done is, if that map1 of I is equals to 0, then I will be doing a continue because I have not found any index to swap, right? So I will give a example. Here A is 1, then B is 1. Let us say C is 2 here. This is the map 1. This is the map 1. And let us say we are having B as 2, and let us say we are having C as 1. and we are having a as 0. Let us say a as 0, b as 2, and c as 1. So let us say this is the mp2. So I have found this first value, and similarly I want to find the first value to swap in my map2. So that is why I have included this statement mp2 of j is 0. Then we have to continue, and once we have found the both the characters, this is the first character in mp1 and this is the first character in mp2. Now I can do a swap. Doing a swap between the two words is nothing but deleting the character from mp1 and incrementing the character in mp2, and deleting the character from mp2 and incrementing the character from mp1. That is the same exact thing what I have done here. I have decremented the character from mp1, that is mp1 of I is decremented because I'm deleting that character, and I am just adding it to my mp2, and I'm just deleting the character, sorry, I'm just incrementing the character from mp2 to mp1, and I'm just deleting the character from mp2. So this is the swap that I am doing. And after doing a swap, what I'm doing is I'm going to call this check function. This check function is going to run for order of 26, so it is very small. So this is nothing but I'm finding the distinct characters. This function is having a two counter variables, that is going to count for mp1 and mp2. And if mp1 of I is greater than 0, I will increment counter 1, and if mp2 of I is greater than 0, I will increment my counter 2. And at the end of the day, I'm returning if my counter 1 is equal to counter 2. That is, both the maps are having distinct characters, equal distinct characters. So that is what this function says, and it will true if it satisfies, or it will return false. So if it returns true, then this swap, then we are doing one exact swap, and that swap comes out to be having equal distinct characters in both the strings. So we return true. Else we want to reset the values. Resetting the values is nothing but exact opposite thing we want to do. What at all we have decremented, we will be incrementing. That's it. So we are actually doing a swap, then we are checking and doing resetting the values. That is what we will be doing in this. And the time complexity for the solution will be at best case 26 into 26 into 26, and this is not at all big compared to 10 power 5 into 10 power 5. So it is very easy to solve using these maps. So I will submit the code as well. So hope you like this solution, and let me know in the comments if there are any suggestions. Let me know please. So until then, bye.